Good afternoon, everyone. It's truly an honor to be here at ISO's Standards Lecture Seminar to share China energy investment's practical experience and the standardization research in spatial intelligence service. The report comprises three focus areas as follows. Part 1. China energy investment spatial information business. China Energy Investment, or central state-owned energy conglomerates, operates integrates coal, power, transport, chemical industry across 31 Chinese provinces and about 10 countries, including the US and Canada, holding assets of 2.1 trillion yuan with 350,000 employees. We have established a powerful brand such as China Energy Omnipotent. We also have market leadership positions, such as we have 60.60% of national coal sales, 12.5% of national power generation, 12.5% of national heating supply, 11.1% of national rail freight. Comparing with traditional energy group, we have two prominent features. Our company named Digital Intelligent Technologies Company, a strategic subsidiary under the China Energy Investment, founded in July 2010 and reorganized in December 2022. Leveraging the Digital Intelligence Technologies Company, our group established the Spatial Temporal Operations Center in 2023 in order to establish the group's spatial temporal intelligence service system and undertake some core tasks, such as operate Spatial infrastructure and platforms, develop terminal products, and promote applications. Currently, the Beidou Spatial Temporal Operating Center is establishing an intelligence service architecture characterized by one map, one network, one platform, and a series of terminals. So what is this? Let me elaborate on each component of this system. The one map as a unified map of the group company is based on spatial temporal data and has constructed service capabilities such as data visualization, spatial querying, spatial editing, spatial analysis, and data collection. China Energy Precision Spatial Temporal Network is a core infrastructure of the group's Beidou Spatial Temporal Intelligence System. It combines self-built and shared resources to establish a ground-based augmentation network covering all group railways and surrounding stations, delivering unified spatial temporal reference and centimeter level positioning. Spatial temporal information platform includes 4 types of infrastructure, which are Beidou, data, computing, and AI infrastructure. And aligned with operational demands, the platform delivers 5 product categories, such as positioning series, safety monitoring, environmental sensing, and enterprise sheets, and so on. As we build our spatial temporal intelligence service system, we deal with a large amount of spatial temporal information business in the energy field. For this reason, we have strong need the support of international standards from OGC, ISO, national standards, and other industrial standards. So let's take a look at what standards we are currently using in the field of spatial temporal information within our group. Part 1. Part 2. The current spatial standards used by the group. Our standardization framework for data governance are critical components spanning 3 dimensions, such as data acquisition, data management, and data application. Our compliance system integrates 2 tiers of regulatory requirements. First, raised by the State Council and the various ministries, including the surveying and mapping law of the People's Republic of China, and so on. Secondly, raised by the Ministry of Natural Resources, such as technical specification for spatial temporal big data. The key standards guiding our platform development is span 2 critical categories. First, raised by the Ministry of Natural Resources, including physical specifications for common platform of geographic information, and so on. Second, raised by other departments, including information technology, artificial intelligence, platform computing resource specification. Turning to the standard governing our spatial temporal survey system, network development, we adhere to a multi-dimensional regulatory framework. First, positioning survey standards from Ministry of Natural Resources, including real-time positioning, rating service, contents, and the date formats of Beidou ground bears representation system, and so on. Next, released by the Ministry of Industry and Information Technology, including technical requirements for Beidou timing terminals, test methods for Beidou timing terminal. Additionally, released by other departments, including Beidou navigation satellite system. Last year, we issued our enterprise standard monitoring specification for ecological management and soil or water conservation under the following circumstances, such as at the national level, multiple newly established and revised laws further clarified corporate responsibility and legal obligations for ecological governance, so implementing monitoring become imperative for our group. During the development of this standard, we engaged expertise across multiple critical disciplines, including remote sensing, environmental science, land management, water conservation, information technology, and legal compliance. The standard was technically adequate by key national references. The standard aims to establish ecosystem quality and soil water conservation monitoring protocols tailored for our group's diverse operations, including coal mining, thermal power, new energy, coal chemical, and transportation sectors. The comprehensive set of monitoring specification for ecological management and the soil or water conservation comprises specialized standards tailored to each of our coal industry, including in coal mines, in the thermal power industry, hydropower industry, and new energy industry, and so on. Currently, we have referenced many national standards to guide our spatial temporal information business, and have also published some relevant standards. There are still several issues. First, the current standards can't meet the urgent demand for standards in all directions of the spatial temporal domain. Second, the existing standards have different focus in terms of scope, definition, and terminology description, which limits the guiding value for enterprise and so on. To address these issues, we plan to conduct research on the standard pathways for spatial intelligence service in the energy industry. This includes developing a standardized system for spatial temporal intelligence service, formulating technical standards for spatial temporal intelligence service, establishing a set of business metrics for the integrated operation and the management of the entire industry chain. The efforts aim to solve three main problems, such as the combination of technical standards specifications for the Beidou and the spatial temporal intelligence service system. Second, the formulation of operation management mechanisms for the spatial temporal intelligence service system. And third, the development of security and assurance management mechanisms. So let me elaborate the research. The research includes three projects. They are Project 1, research and development of technical standard specification for the spatial temporal intelligence service system. Project 2, research and development of operational management mechanisms for the spatial temporal intelligence service system. Project 3, research on security and assurance mechanisms for the spatial temporal intelligence service system and the implementation of data security management. The achievements we have made include 38 technical standards for spatial temporal intelligence service system that we have developed, a set of business metrics for 12 different application scenarios, 7 standards management system to ensure that the long-term operation of the spatial temporal intelligence service system. 4 management methods for the operation models of BEDO, high precision positioning service, a comprehensive cyber security production system and its management approach. 7 sets of security and management requirements for energy spatial temporal data. For Project 1, our focus areas are developing safety and privacy production standards, promoting and implementing these standards. The challenges we face mainly lie in ensuring safety and privacy, dealing with the complexity of technology and achieving data interoperability. The Spatial Temporal Intelligence Service System standard we have established and covers 10 dimensions. We plan to develop 38 technical standards related to the Spatial Temporal Intelligence Service System. This includes basic terminology for enterprise spatial temporal intelligence service, classification and coding of enterprise spatial temporal information elements. We also have 12 business metrics for the integrated operation and management of the entire industry chain. These cover requirements for enterprise online monitoring spatial temporal applications, emergency command spatial temporal applications. The research focus areas for Project 2 include service quality management, resource scaling and optimization. The challenges we face in this project mainly revolve around data integration and governance, service quality management, and the security and the privacy production. We have developed 7 standardized management systems for long-term operation, which include management standards for enterprise spatial temporal information resources directioners, regulations for the update management of enterprise spatial temporal data. Additionally, we also plan to research 4 management methods for the operation models for BEDO, high precision positioning service. For Project 3, we focus areas for the security assurance mechanisms and data security management. Implementation in the spatial temporal intelligence service system includes developing data security production strategies, selecting and applying data encryption technologies, researching and applying data destination technologies. The challenges we face in this project mainly revolve around establishing and enforcing data security standards, as well as data encryption and privacy protection. The cybersecurity production system and the management methods include a guide for building the BEDO and the Spatial Temporal Intelligence Service System, cybersecurity production system, and the network and the communication security management methods for the BEDO and the Spatial Temporal Intelligence Service System. The security production requirements and the management methods for energy spatial temporal data include security requirements for enterprise spatial temporal data processing, security technology requirements for enterprise spatial temporal intelligence service, security testing standards for enterprise spatial temporal intelligence service. That concludes our presentation. We warmly welcome all experts to visit Beijing and our group to guide us in conducting more professional geospatial information standards research. Thank you for your attention.
Thank you very much. Massive long list of standards there. I can see that you've got your work cut out in trying to implement them. But obviously, you chose a really good tool to monitor the energy grid for spatial and temporal. So yeah, there's some good work there. Thank you very much indeed.